Okay, I think we've hit critical mass. Let's go ahead and get started. Hello, everyone. Good morning, good afternoon, or good evening, depending on where you're joining us from. My name is Keith Freeman. I'm the Director of Marketing for SSP Innovations, and I'd like to welcome you to our presentation today, Cityworks and SSP Innovations, Better Together. Today's speakers will be George Mistakis and Ian Martin. George Mistakis is the Vice President of Enterprise Solutions for Cityworks and has 25 years of experience bringing GIS-Centric asset management and customers together. The culmination of these efforts is reflected in Cityworks software, where George has been involved in conception, growth, and expansion since 1996, with the end goal always being to provide meaningful solutions that help organizations be healthier, more sustainable, and safer while increasing their level of service and reducing costs along the way. Ian Martin is the Director of Asset and Work Management Sales at SSP Innovations and has over 20 years of experience in the electric and gas industry. Ian's expertise lies in process and technology consulting to design and deliver asset and work management, mobile workforce management, and design and distribution design solutions using innovative product-focused offerings. Just a little housekeeping before we get started. We'd love to hear from you, so if you have any questions, please enter them at any time via the Q&A button on your screen, and we'll answer those at the end of our presentation. Secondly, just in case, please navigate to the View Options button on your screen and select Fit to Window if this is not already selected. And finally, a recorded version of this webinar and PowerPoint will be made available in a follow-up email. With that, I'll turn things over to Ian Martin. Ian?
Thanks a lot, Keith. And thank you to our attendees. We appreciate you guys taking the time to join us today. We're going to do a little bit about SSP and Cityworks to kick this thing off. So SSP Innovations has been in business for over 10 years. Our core competency is GIS consulting and implementation services. And the primary markets that we serve are utility companies, pipeline operators, and telecom providers. But most of our business is focused on electric and gas utilities. SSP is a Esri Platinum partner, and we work closely with Esri industry and product teams and our peers in the partner community like Cityworks. Here are a few stats that describe the SSP of today. While there's been a lot of growth and change over the past year, the one thing that has remained consistent is our focus on Esri solutions. So 100% of our work is on the Esri platform. And now I'll hand it to George for a little bit more about Cityworks.
All right, fantastic, Ian. Thanks a lot. And thank you, everybody, for joining us today. It's pretty exciting to see so many of you on this presentation. Similar to SSP, we too are a geospatial solution provider, and we were founded on Esri and ArcGIS as well. Our history with Cityworks goes back to 1995, but we actually got our beginning in 1986 when we provided mapping solutions for the U.S. Forest Service. But in 1995, we saw a gap in the municipal and utility market when it came to leveraging GIS for asset and work management. And the idea for Cityworks was launched at that time. And today, more than 700 organizations with more than 40,000 users comprised of water, wastewater, facilities, streets, traffic, parks, airports, transit, and of course, electric and gas organizations use Cityworks to improve and maintain the health of their infrastructure, which more than 80 million people rely on worldwide. And as Ian mentioned about SSP, we're an Esri partner, Esri Platinum partner as well. And this is an important distinction, I feel, because out of their 2,000 plus network of partners, only 15 of us are at the Platinum level. And Cityworks is the only provider of asset management permitting solutions. And I think this is an important differentiator because it reflects a certain depth in our commitment to Esri, and not just their technology, but their overall direction as well. And I think this is crucial because when you select an asset management system, you will use that system for at least the next decade. And so it must work well with Esri and with ArcGIS. And I believe that interaction has to be the absolute best because all of us here that have joined this webcast today, all of us have chosen to use ArcGIS to solve challenges. And in fact, you've created more content, data, and maps, and you've provided more ArcGIS-based tools to gather and deliver information to your users than at any other time. And that's not going to decline. And so our aim at Cityworks is to build software that is additive to ArcGIS so that you can round out your workflows. We think of Cityworks similar to ArcGIS, where on the one end of the continuum is a system of engagement that enables and improves interactions with your customers and citizens. And on the other is a system of insight that brings to light critical information to help you plan your next moves. In the center is a system of record where all those work order, service requests, inspections, and permits accumulate and come together on a GIS-centric foundation. And for Cityworks, GIS-centric is comprised of three main themes. The first, probably the most important, is your infrastructure assets should reside in one system exclusively, and that system should be ArcGIS. Duplication and synchronization of your GIS to other systems should not be your norm. Your asset management system should conform to your GIS, not the other way around. And this should be the case for both spatial and non-spatial assets. The second, use web maps in ArcGIS and in Cityworks, and go so far as to use the same web maps in both. Cityworks comes ready-made with back-office web and mobile applications to suit any business need. But there may be times where, for certain use cases, you guys may want to use something like Collector or Survey 123. And so the web map not only brings Cityworks and ArcGIS together, it also establishes seamless connections to Esri's apps so they become an intrinsic part of your workflow. And lastly, configure first and customize only when you need to. Just like ArcGIS, Cityworks is very configurable. This is facilitated by an agnostic workflow engine that allows you to define the workflows you need in the exact way you need them, and directly to your assets in ArcGIS. Similar to ArcGIS, if you get to the point where you need customization, Cityworks provides a common framework in which that can be done. And Ian will show us a little bit of that a little later. And those customizations are supported through updates and upgrades, just like you would expect with ArcGIS. Ian, back to you.
All right, thanks. So as you just heard from George, Cityworks has a long history of providing GIS-centric asset management solutions. And SSP has a lot of experience delivering technology projects to the electric and gas GIS industry. So we decided in 2016 that we'd partner and look to expand the use of Cityworks asset management system platform into the electric and gas utility market. This started with an integration of Cityworks and SSP Lifecycle to support capital design workflows, and importantly to support capital design project estimating using compatible units. Most recently, we've expanded our focus into Cityworks Operational Insights for risk-based proactive asset maintenance. And we'll be talking about each of these offerings today, and also showing some targeted demonstrations. Before we move on to talk about the capital design workflows, Keith is going to conduct the first of our polls to hear about your plans for graphic work design. Having some technical difficulties with our poll.
Excuse the difficulty. So you know what? Let's pass this one, Ian. Is it just
okay? We'll pass that. We're going to assume that everybody's interested in capital project work design, so we're going to do a little bit more talking about that. So Cityworks provides a lot of capability to utilities around the utility business processes, specifically around service requests, work orders, and inspections. But when it comes to capital design and capital project estimating, there's additional capabilities that are beneficial. And Lifecycle provides a lot of these additional capabilities and complements what you've got inside of Cityworks. So Lifecycle provides a work request lifecycle. It gives you the ability to step through a prescribed workflow It gives you project and job tracking so that you can track the status of your jobs at various stages through that life cycle. You can track ancillary project requirements through process checklists. And you can do compatible unit estimating, of course. And then when it comes time, after that design's approved and you're ready to go into construction, you can do material reservation, including reservation and dedication of materials through Cityworks Storeroom. You can do as-built reconciliation after the construction is complete, and you enter your actual quantities into your design project. And Lifecycle provides that central collaboration hub for all of the information that you're going to be sharing throughout the course of this of the project, and that goes for when you're working inside of Cityworks and when you're working inside of Lifecycle. So there's a seamless transfer of information, and in fact, Lifecycle screens can be embedded inside of Cityworks as well too. And this is made possible through Lifecycle's powerful integration framework, but like you heard from George, there's also a lot of configurable capability that's present in Cityworks that allows you to take advantage of applications like Lifecycle. So Lifecycle manages work via a process-oriented workflow that moves a project through a set of pre-configured states. And along the way, individual actors execute assigned tasks that drive the work request through each of these states and seamlessly share data with other systems along the way. The process is configurable to align with different utility business processes, but a consistent pattern is around initiation, where a customer makes a request, planning, where an engineer or designer builds estimates and compares design scenarios, approval, where a supervisor approves the design for construction, construction, where materials are requested and a crew completes the construction project, as-built, where changes are recorded and actual equipment, labor, and material costs are reconciled with that estimate. And then finally, closeout, where the work request is closed and billing and plant accounting records are updated. The building blocks of the work process are equipment, labor, and material resources. Now, these lifecycle resources map directly into Cityworks Elm. So lifecycle resources equal Cityworks Elm. There's a direct correlation between lifecycle resources and the Cityworks Elm. And Cityworks supports estimating the same way that Lifecycle does, but it's not standards-based. What Lifecycle provides is the ability to give you support for engineering and construction standards. And this capability is applicable not only to electric and gas utilities, but to any capital construction or asset maintenance workflow. Lifecycle utilizes equipment, labor, and material resources to create compatible units. The compatible units are linked to your engineering design or construction standards. And those compatible units can be composed of a single asset, for example, a transformer, or many component pieces of material, like a pole frame, the individual nuts and bolts and frame arms and braces and everything like that. They're not necessarily pre-assembled, but like an IKEA chair that you pick up on the weekend, they'll have all the component parts that you need to assemble it on site. And CUs vary based on work type. You have different labor, equipment, and material needs based on whether you're doing an install or a remove, for instance. And all of these costs roll up to establish the cost estimate for a particular design job. So we've got our second poll. We're going to try to make this one work, and we're going to ask about how you guys utilize compatible units.
Let me see if I can get this one going. Okay, I think I've got this one. 1, 2, here we go. Launching it. There we go. us a minute or so.
So we'll just take a few seconds to get some results back for that, and then we'll move on.
It's shifting. I think it's slowed down. I think we got our results. I'll end it and share it out.
Okay.
Here we go.
So looks like a pretty even bag across the board. Even though I just defined what CUs are, we get some what are CUs answers. So they're either jokesters or not paying attention. So anyways, we'll talk a little bit more about that as we get into our design process. But before we do that, I want to talk specifically about how Lifecycle integrates with Cityworks. So what we're doing, the foundation, like we said, were those resource records where we've aggregated that to create CUs or MUs being collections of CUs. We synchronize that with the Cityworks Elm, and that's handled periodically so that we make sure that we keep material, labor, and equipment costs up to date in our CU library as well. And then from there we can fall into Lifecycle's structured, pre-configured workflow. So we can create work requests. We can do design estimating with those CUs. We can go into the design approval process. And these are things that typically happen outside of Cityworks and before you need to engage with Cityworks. And so at the point where you've got an approved design and you're ready to create that Cityworks work order, we can initiate that and hand that information over to Cityworks. So we create that new work order. We send over the estimated materials, and then that process can then start to work through the rest of its workflow. So we can go into the point where we're going to order materials and reserve those via the storeroom. We can assign the construction project to a crew. We can perform the field work. We can capture all those as-built material records. And typically the way that this happens with an SSP implementation is that you've got this unified process workflow, this digital workflow that's going to support that with SSP Lifecycle in the office and with MIMS in the field. And then finally, when those as-built are captured and you've got those GIS updates back in the office, you can commission those assets and update your operational model, including making additions to the utility network. And then you can send that as-built information over to Cityworks where those materials can be applied. You can assign GIS assets. You can collect the actuals to compare against your estimate, and then begin your asset inspection and maintenance cycle. And along the way, you're closing out that lifecycle work request. So the next thing that we'll do is go into a demo. I'm going to prepare to do that demonstration here. Share my screen. So what you're looking at now is SSP Lifecycle. And what Lifecycle provides you with when you first log into it is a view on your work. So this dashboard is going to give you work that's been created by you or is currently assigned to you in whatever state that it's in. And then you have different panels down below that are configurable based on the way that your business processes are set up, that show you things like unassigned work, job requirements where you're not the current, you don't currently have control of that job, but you have some ancillary task that's been assigned to you. And then finally, unassigned requirements where you can drop in based on your role and pick up something and perform some work. And before we go in and talk about new work requests and doing estimating, I'll just show you real quick this notion of the compatible unit and how you can do compatible unit library management inside of Lifecycle. So inside of Lifecycle, you've got the ability, we'll just do a search for an existing compatible unit like an OH45, 45-foot wood pole. We'll load the details on that. You see some metadata, essentially, about that pole. What's its name? What's its description? What's its unit category, subcategory? Is the compatible unit active right now? Can I use it on estimates? What department is it valid for? What's its FERC accounting code? Does it have as-built extension attributes? Things like that. So we have that detail up top, and then down below, we've got the resources that are associated with this particular compatible unit. So you can see that in this case, we've got a 45-foot Class 2 pole, and we've got the material, the warehouse specification number for that. So that's something that we would, in a Cityworks implementation, pull from Cityworks storeroom. Then down below, we've got the equipment that's necessary to install that pole and the labor that's necessary to operate that equipment and complete that work. So that's the way that compatible unit is authored. And you can build new compatible units, you can edit existing, and then you can also aggregate compatible units into macro units. So let's go back to the dashboard. And I've already created a work request, but I'll show you how you can take an incoming work request before we go in and look at that. And there are multiple ways you can receive it from an existing system like Cityworks. There might be a capital project maintenance request, for instance, that might flow into Lifecycle. This could be a call to a customer, to the engineering department. You're going to pick the job type, and you can have many, many different types of jobs. You're going to pick the department that you're dealing with. You're going to pick the budget classification for that work. And then based on that budget classification, you'll have a charge code that you can pick. So we'll look at what that means by looking at a work request that we've already created. So for this particular work request, we've got an overhead residential distribution job. We've described it as work that's going to be used to convert from overhead to underground to serve a 6-lot residential redevelopment. We've got a priority on it. We've got our charge code, our budget classification, and we've got some dates that are important for calendar reminders and contact details for the person that requested this work. And then down below, we've got information that's relevant to this job so that we can go in and see it. If this is the first time that I'm coming in to look at this this work request, I can go down here and I can see details. Like somebody's already attached construction permits for me. I can see, click this link right here and see what's going on at 4499 Roan Road. And what this is doing is opening up a portal web map where we've done a geocode request for that particular location, and I can see that relative to what's going on inside of the service territory. I can zoom out a little bit and look at how that is going to impact what's going on around me. I can come back to this work request, and I can go and look at the checklist items that have been created. So we've got in the checklist items, these are things that can be created and managed independent of for different job types, and you can set these up to have as much or as little detail as you need. So here what we're doing is we're saying we need initial customer contact, a site visit, we need permits for the construction, and then eventually we're going to need to issue a bill. Like I said, these can get very detailed. In this case, we've got just a simple workflow or a simple checklist going for that. So now we're going to fall into that estimate. And we're going to do a non-graphic estimate today, just in the interest of time. And what we've done is we've set up this underground dip to a 100 kVA pad mount transformer. And that's going to help, that's going to serve the power out to that 6-lot redevelopment that this developer's doing. And I've been on the phone with the developer, and she's been telling me that she wants us to pull a conductor out to the meter pedestals. And so I've done that for a few of these. I've already done the dip pole, and I've already done the transformer, and so we've got those costs right there. But she wants us to pull secondary out to these meter pedestals. So I've done it for all of them except for this number 60 right here. So what I'm going to do is start editing, and then I can pick the compatible units that I've created for this work location 50, and I can copy them down here to work location 60, and then that's going to update my raw total, my materials, my equipment, my labor. So now my design is complete, and I'm going to move back to the work request, and I'm going to submit this for approval. First, I'm going to skip over that graphic design step, and then I'm going to submit this for approval. And this is where the designer or planner would make an assignment to the engineering supervisor. Now, this can happen interactively, like I'm doing, or it can be something that's process specific. So it can be something that's driven by the workflow. I'm going to save that, and then we'll go back in, and you can see now that this job is pending approval up at the top right-hand corner. It's pending approval, and now I can approve this work. And then finally, once that transition is complete, I can create a Cityworks work order for this particular work request. So I'm going to create that Cityworks work order, and it's telling me that it's created Cityworks work order number 2493. And the way that we affect that integration is to create an attachment type down here. So we've got this link now back to Cityworks. So I'm going to click that link, and it's going to open up Cityworks for me. And it's going to open it up right to that work request that I created. Now, I've got the 2493 work request that was created. I've also got information on what the originating lifecycle work request was, this 1721. And now I've got all this other information. I've got the work order metadata. I've got location information, 4499 Rowan Road. I can look at that inside of Cityworks. And then we've got other detail that we can review while we're inside of Cityworks. So we can come in and we can look at the material needs that we've got for this particular project. So we've got a list now of material, and this is broken down based on the individual material item stock codes that are stored inside of Cityworks storeroom. We've got the labor that's going to be required to do this construction. So we can see the apprentice lineman, the crew foreman, the journeyman lineman, the hours that are associated with each of those roles, labor roles. And then finally, we've got the equipment that we can review. So we can see all of the equipment based on type that we're going to need and the hours that we're going to be operating that equipment. And then finally, we can go down to the cost summary, and we can see what those estimated costs are for that job. So in this case, we're looking at $16,922.61. And it's specific because if I come back over to our estimate and have a look at that, it's going to match exactly. So what we've done is we've got that direct integration now between those compatible unit costs and the ELM costs inside of Cityworks. And what happens then is that we can advance through the process here, and then eventually you'll end up with your actual labor costs, your actual equipment costs, your actual material costs, and you can do reporting on your variances inside of Cityworks. And when you get those as-builts back, you'll also go back to your work request dashboard, and you'll be able to see the assets that have been installed as part of that work request. So with that, I'll conclude this short demo, and we'll go back to the presentation to pick up where we left off.
All right, sure, all yours again.
So once those assets are in the ground, it's time to maintain the plant that you've installed. And our focus here is on proactive maintenance, as we talked about. That's like the next area that SSP and Cityworks are getting into together. So, got a request remote control, guys. I'm sorry. Still getting the hang of this. So historically, utility asset management's been somewhat of a mixed bag. Some folks use the GIS as a system of record. Others use a third-party enterprise asset management system. Some of you guys even are still using Excel spreadsheets and Access databases or Shutter, even paper, and we're not judging you. But regardless of your system, you're probably really good at reactive asset replacement. It's pretty hard to overlook a pole on the ground or a blown transformer. Those assets will run to failure by whatever means. Most of you are pretty good at proactive asset inspections and maintenance. In a lot of cases, this is because there's some regulatory driver in place, but we know you do it anyway. Some of these processes are still paper-based, but we're definitely seeing a trend towards digital and even mobile work processes. But proactive maintenance is lacking. We need to do more with the tools that we have at hand. SCADA and AMI can help. We can rely on those sensors, but they don't cover all asset types. SCADA gives you your operable devices, AMI gives you your meters, but what about all the other stuff in between, the stuff that's holding up everything? Cyclical inspections are good, but they're not targeted. You're selecting 10% of your poles for annual inspections, regardless of their risk profile. Targeting assets based on attributes, like manufacturer code or a lot number, is a start, but it's typically a one-off in response to a specific event. A windstorm rolls through and turns over half of your metal poles, or a recall. So what we really need to do is dynamically analyze our GIS attributes to create risk models for targeted assets. And Cityworks Operational Insights provides that capability. So I'm going to hand it back to George so he can talk more about why to use Cityworks Operational Insights.
All right, thanks, Ian. I feel like where this conversation is headed next year has a lot to do with becoming smarter in the way organizations work, right? And in my mind, that rolls up into the qualities that they exhibit, which are they're safe, they're well run, they're livable, they're healthy, prosperous, and they're sustainable. At its core, working smarter is about sort of this digital transformation you're undergoing and what you're doing to stitch people and your systems together so that you can improve your outcomes. And so the behaviors that you'll find these organizations display they're very strategic and forward-thinking about how they do things. They will have a real-time awareness of what's happening. The collaboration across their departments is pretty much intrinsic and part of their culture. They create really good engagement with customers and with citizens through destination portals. And of course, because of that, then they're open and transparent. But where we're going to focus on here next is how they drive their decision based on the data that they accumulate and that they have. And this is critical because you face enormous challenges that are not going away. Your infrastructure continues to age and funding is not keeping pace. The availability of your people to help improve that infrastructure is not keeping pace either. And of course, you have regulatory requirements that you have to meet. And even though you're doing things right, you still have to report. And so just generally, you've become accustomed to doing more with less. Well, the way we feel the situation can be improved is to transition from managing your assets to asset management and to get away from, basically reacting to your issues and more towards a strategic planning approach. And admittedly, that is not an overnight process. There's a whole industry around helping organizations, transform that. So you're not going to flip a switch and magically, voila, you're there. But if there's one thing you can do, and you can start doing this tomorrow, is to identify your riskiest assets. And the data you need in order to make that happen lives in your GIS today. And it's there for you waiting to be used. So let's just take a quick look at what this is all about, what risk is all about. Foundationally, it's an equation that does require thought, but it's also straightforward. The probability of failure of an asset failing is one of the variables that you have to determine. So for example, perhaps it's the age or the type of material, and that gets multiplied with the consequence of failure. So for perhaps environmental consequence of that, or the service interruption, or how much it would cost for you to replace it or to fix it. And the product of that then becomes your business risk exposure. And what's awesome about this approach and why we like it so much is it's a common language across all your services. It also helps you better focus your resources and your funding. And on top of being more robust, transparent, and easily repeatable, it is also defensible. Nobody can tell you this is the wrong approach or incorrect thinking. Ian, I'll hand it back to you and to have you walk us through an example. Thanks.
Great. Thanks, George. So Cityworks Operational Insights provides many configuration options for you. What we're going to do today is we're going to talk about polls, and then I'll show you a live example where we've done some analysis with transformers. And the first step to doing anything with Insights is to set up an asset strategy. So an asset strategy is a risk-based predictive algorithm that targets specific assets. Again, in this case, we're going to be talking about polls. So then what we do is we define our risk factors for the POF, the probability of failure. This is the probability that an asset might or will fail. Risk factors for polls include condition. Is the pole in good condition or poor condition? Material, is the material wood, concrete, or steel? Because that's going to impact the likelihood of failure. And age, barring material defects, older poles are more likely to fail than newer poles. So we can assign factor ratings to each of these. And you can see some of those factor ratings for age on the right-hand side there. Older poles, higher score. Younger poles, lower score. Then we define our risk factors for COF, the consequence of failure. And so this is the consequences of an asset failure on the utility and the community. And again, the risk factors for poles include height. Taller poles typically carry higher voltage lines. Class, heavier poles carry controllable equipment and transformers. And use, the failure of a service pole is going to have a limited impact on anybody but the customer that's in that that service is attached to. But the failure of a transmission tower may affect thousands of people. And then finally, we can calculate our business risk exposure. As George just introduced to us, BRE is equal to POF times COF, lots of acronyms. But running this calculation allows us to analyze assets and determine where to spend our maintenance dollars. So what we'll do next is look at an example, but before we do that, we're going to conduct our final poll and learn more about your current EAM system.
All right. All right.
So we'll give you guys just a few seconds to complete that.
Clear winner so far. I think we're
Gives
good.
me a little bit of time to get the demo ready too. All right, we good?
We're good, yeah. I think we got critical mass here. I'll end it.
Okay, sounds good. Yeah, so thank you for that. Well, we got a healthy representation of Cityworks folks on the line today. That's by far the biggest category, and then following closely on that is GIS. So good stuff. So we appreciate that. What we're going to do now is switch to another live demo, and I'll show some capabilities of Cityworks Insights as it relates to electric utility assets. So what you're looking at now is the Cityworks Insights analytics dashboard. And what we've done here is we've created an asset strategy, and now we've selected that, and we're building it up based on transformer type. And we've built a calculation. This is a BRE calculation that's based on some risk factors that we've already assigned. And we've got our probability of failure, our consequence of failure values, and then those have been calculated to reflect this business risk exposure. So you see that most of our assets, most of our transformer assets, are very low risk. They wouldn't impact operations too heavily. But we've got 775 transformers on the other end of the spectrum that are very risky assets. So they have the potential to to, you know, create significant issues if they were to fail. So now we want to take the results of this calculation and do a search, because we need to find out what those assets are, what they actually are. So what we've done is we've done a calculation search now using that the analysis calculation that we just did, and we've selected where the business risk exposure is greater than 20. So just to be clear, most of our POFs and COFs maxed out at 5. So the highest value that we can have for this BRE in this example is 25. So we're looking at stuff that's very risky here. And we've run that analysis, and we've got those 775 results, and we've got asset codes that are associated with those, and we've also got, you know, X and Y locations and all that important detail that we need. And we can use that X and Y location. We can generate an EURL, and we can load that up as a map layer inside of a portal web map. So let me go back out, and we'll look at that heat map that shows what it is that we're seeing here. So we're seeing that we've got some industrial areas: Raytheon, Plastipac, Praxair, a town center, so a shopping center up at the northeast corner. These are all areas where we've got some probably some pretty large transformers that are going to affect, you know, a lot of people if they were to fail. But we've got this little outlier here in the east by Lake Ray Hubbard. So I'm going to go take a closer look at what's going on over there. And we can see that we've got, you know, some sort of something happening here. We'll zoom in a little closer, and we'll pick on one of these transformers here. So we can see that that's certainly one of our high-risk transformers. It's got that BRE of 25. And then we can see the specific asset facility ID for that thing, and we see that it is it's a 2000 kVA transformer. So we've got, it's on the high end of our size for a transformer, and it's going to have it's serving power to a significant facility. So I've created a map over here that also has that same map as the backdrop, but I've created a dashboard. And so what we're seeing here is that this is the wastewater treatment plant for the city of Garland, SSP town, as it were. And all of the transformers in that area hit that business risk exposure threshold of 25, the max threshold. And we can see those individual transformers lined up in this dashboard, and we can see that same detail. So what we're doing here is we're showing how you can take advantage of the operational insights, Cityworks operational insights. You can leverage that against your ArcGIS portal implementation or ArcGIS Online implementation, and you can access information and visualize that so that your asset managers and designers and planners can take advantage of that information that you've analyzed and visualized. So with that, I'm going to hand it back to the presentation, and then we'll take our next steps.
And take control as well, Ian.
Yep. So with these insights results, now what else can we do? That's the next step. So there are business drivers that insights can help you with. You can look at what your capital replacement budgets are going to be in future years. You can look at establishing new O&M inspection and maintenance budgets. So this goes back to what George was talking about how you prioritize your spending on maintenance or capital, or even potentially reducing service if there's not a lot of risk in a particular area. You can also look at technology. So you can create new Cityworks inspections or work orders. You can send capital project work requests to Lifecycle. So where you need to replace one of these high-risk transformers, or where you need to build out additional capacity for a capital project plan. And then you can integrate this into other systems, your mobile systems, your distribution planning systems. You can support other business processes using this insights data. So with that, I'll hand it back to Keith, and we can go into the Q&A portion.
Excellent. Thank you, Ian. Just a reminder, please be sure to use the Q&A button on your, to enter your questions. Looks like we have a handful have already come in, some during your demo as well. The first question, can you talk more about your mobile offerings?
Yeah, so there's a couple of mobile offerings that are available between SSP and Cityworks. On the SSP side, SSP recently completed an acquisition of TC Technology, and so TC Technology's MIMS platform is available and has been integrated into the Lifecycle with the Lifecycle product, and that's really around graphic work design, capital project design, and as-built processes. And so you can, when you're talking about a Cityworks implementation, you can look at it breaking down on like job role. You can see folks that are using, that are needing to do more capital projects and design and as-built processes using MIMS, and then folks that are more engaged in operational activities, maintenance and inspections using Cityworks Mobile for a lot of those asset-centric tasks. So that's kind of how mobile fits into this.
Excellent, thanks, Ian. The next question, Ian mentioned offerings to Insights for ArcGIS Online. Can this also work with Insights for ArcGIS?
Yeah, I'll take this one, Keith. This is George. The answer is yes. And in fact, Insights for ArcGIS is what inspired the name of Operational Insights. And not just in terms of operational insights, but in terms of the entire Cityworks software solution, Insights for ArcGIS can be used. So absolutely, you could take those result sets that Ian was showing us and bring them into Insights for ArcGIS and do further analysis and mash it up with other data so that you can kind of start to get vision and glimpse into where you need to apply your resources. And then you can represent that data in a variety of ways, and as core diagrams, as bar charts, et cetera, and so forth. And of course, you can publish and host those results. But, just the day-to-day of Cityworks, you could do the same thing with. So if you want to look at cost trends for a certain material or a part, if you'd like to do the same for labor, things like that. Insights for ArcGIS is a phenomenal tool for you to get those analytics out of. And in fact, we have a companion product named Cityworks Analytics that comes pre-configured and can be stood up inside of Insights for ArcGIS that will kind of scour your Cityworks deployment and bring back into cards and workbooks those views, those operational views that are happening in your organization.
Thanks, George. Next question, Ian. How do you get material labor data if using SAP Financial System? Also, how do you reserve materials in SAP inventory?
So the mechanism for this is the same. If you've got an SAP Financial System or an SAP EAM, it's essentially the same process for interfacing with Cityworks. You'd use some sort of open API like the process interface. And then you do a synchronization between those SAP tables and your resource tables inside a Lifecycle. And when it came time to reserve materials, you would send over that material request just like you'd do if you were sending it over to Cityworks Storeroom. So that Lifecycle API supports that SAP interface as well.
Excellent, thank you. Next question. Is gas leak processing provided in Cityworks or Lifecycle? Are things such as leak classes and compliance dates captured?
Yeah, I think that I'll take it, and then George can chime in if he wants to after I've had a go at it. I think that this is something that is probably supported in both Cityworks and in Lifecycle, especially with the integration with MIMS. So you have the ability to do leak survey, to do leak investigation, And if you've got assets that are inside of Cityworks, you're going to want to do that through Cityworks, and you're going to want to, set those up that way. So that's, things like leak classes and compliance dates are absolutely configurable. George talked about that inside of Cityworks. Configure and then configure first, and then customize if you need to. And that's kind of the same approach that SSP takes with Lifecycle and MIMS. So I think this is an example of a utility business process that's absolutely supported by Cityworks and by Lifecycle.
Yeah, I think the only thing I would add there, Ian, is to just maybe get a little bit more specific. You could do that either through a work order in Cityworks or through an inspection. And both of those are configurable sort of aspects and elements inside of Cityworks. And yes, it is absolutely supported.
Great. Thanks, George and Ian. This question came up during the demo, so I'm not sure if the context is there, but it says, does estimate change depending on the rate the worker gets paid? And I know it's been answered, but I figured, Ian, you may want to answer that again.
Yeah, so that one came in through the chat window. And basically, when we're talking about the labor estimate on a project, that is based on the job role. So that's typically a blended rate that's been pulled out of your financial system. And you assign those labor roles to those compatible units, and so there's that cost that's usually captured on an annual basis, looking back at historical labor rates. When you do the actuals on a project, and this is where, when you're doing your Cityworks actuals, you're actually capturing who did the work, like which person, which journeyman lineman, which apprentice lineman, which crew foreman. They're filling out a timesheet, and so you get their actual labor rate, and that's where you see the difference between the estimate and the actual come into play in some cases. It's not only differences in the amount of material that you use or the amount of time that you operate equipment, but it's also differences in the individual labor rates for different roles inside of the organization.
Thank you. And then as a follow-up to that answer, I think George answered this one, but this might have been mentioned already. What factors determine the probability of failure? What are those figures coming from that makes sense? Where are those figures coming from that make that up? And George,
and this is and this is applicable to both probability of failure and consequence of failure. We look to your GIS to get those values. Our philosophy is that you've built this incredible system of record, and over years and years, you engage providers to help capture the information. And so you've got this great repository of information that's in there inside of GIS. Utilize that. So just some examples that I'd written in the chat window was for probability of failure, it could be something like the age of the asset. It could also be the manufacturer. It could also be the coincidence of, if we're talking about water, perhaps even gas, it could also be the soil type that infrastructure lives in, because sometimes there's an incompatibility where there's a situation where the soil type affects the degradation of the piece of infrastructure. So, and you could have the same things above ground as well. Maybe it's facing the sun kind of thing, and so it gets beat up more. So yes, I think that absolutely those things are there for you to use, and we encourage you to look at them and to use them. And if there's one call to action after this webcast, is, don't necessarily run out and, okay, I'm going to get operational insights, even though that'd be awesome if you did. But take a look at your GIS and start to look and see, what are the bits and pieces of information that you have that you could start looking at to say, yeah, this would be a good fit for probability of failure, or this would be a good fit for consequence of failure. And we'd be happy to let you try operational insights so that you could start playing around and creating different risk profiles so that you can test it one way and test it another way. And what's beautiful then is that you could take those results and map them and start to get a really good picture as to what's happening out there. So if you have an interest in that, do not hesitate to reach out.
Thank you, George. And we have another one. What about gas leak processing, leak classes, and compliance dates?
Yeah, so that one, we ended up answering that one, Keith. I think it came in through the chat window, but then also through the QA window.
Yep. Okay, gotcha.
Yeah. Yep.
Finally, the last one, asset registry would be good, along with SAMP would be a good start. I'm not sure if you saw that one.
Yeah, I think that was more a statement, and totally agree. And from my friend Peter Godfrey.
All right, well, it looks like we've covered all our questions. If any are more out there, let us know. As always, if a question comes to mind after this webinar, please reach out to Ian and George. You can see their email addresses on the slide you're looking at right now. Our next stop for both companies is GeoConnects this coming November in Dallas. If you're there, please stop by our booths and say hi. And finally, a recorded version of this webinar and PowerPoint will be made available in a follow-up email. Thanks for joining, everybody. And also, George and Ian, thank you as well.
Thanks a lot.
Thank you.
Appreciate it. Thanks, everybody, for joining us today.
Thanks, everyone.